Welcome to the Deep Dive. We know you want to stay sharp on what's happening in machine learning without drowning in papers, so today we're looking at something pretty cool.
Yeah, it connects LLMs, large language models with political surveys, specifically these adaptive questionnaires.
Right, the smart ones that tailor questions as you go, like those quizzes trying to match you with political candidates.
Exactly. They use statistical models to pick the best next question, optimize the whole thing. Very common in political science now, especially with voting advice applications or VAAs.
But there's a catch, isn't there, when they first start up?
The cold start problem. Basically, no initial data to train that statistical model. So for the first users, the question selection is, well, not very adaptive yet.
That's kind of random.
Pretty much, which isn't great for getting good data or for the user.
So the big question in this paper we're digging into is, can we use models like GPT-4 to generate synthetic interaction data?
Fake it till you make it data.
Sort of, but fake data to pre-train the survey's model, to overcome that cold start, give it a foundation before it meets real users.
That's the essence of it. Can LLMs generate useful enough data to give these adaptive surveys a leg up right from the beginning?
Okay, let's get into the paper itself then. What exactly did the researchers set out to do?
Well, first, they wanted to test if GPT-4 could actually generate believable survey answers, specifically for political candidates.
Believable how? Like reflecting actual political stances.
Precisely. And then the crucial part. Could this synthetic data be used to pre-train the statistical model behind an adaptive political survey and make it work better from day one?
And how did they test this? You need some ground truth, right?
Absolutely. They used existing data from a real system SmartVote. It's a popular voting advice application in Switzerland.
So they had real data from real candidates answering real policy questions.
Exactly. A solid baseline. So they prompted GPT-4, asking it to answer the SmartVote questions as if it belonged to various Swiss political parties.
And then compared GPT-4's answers to the real candidates.
Yep. Looked at the distribution, the patterns, whether it captured the nuances between parties.
Okay, that makes sense for evaluating the data generation. But what about the pre-training aspect?
Right. So they took that synthetic data generated by GPT-4 and used it to initialize the statistical model of a simulated adaptive questionnaire.
Simulated, okay.
Then they compared its performance against a model that started cold, randomly initialized, no pre-training. And they also benchmarked against what they called an oracle questionnaire.
An oracle, like perfect knowledge.
Kind of. It represents the best case scenario, knowing the ideal starting point. So they measured how well the pre-trained model predicted user answers and recommended candidates compared to the cold start and this oracle.
Okay, so what did they find? Did the GPT-4 data actually work?
It did, surprisingly well, actually. Finding number one, GPT-4 was pretty accurate in generating answers that reflected the different Swiss party perspectives.
Oh, accurate.
Get this, in some cases, the answers generated by GPT-4 were actually closer to the average party line than the answers from some real candidates from that party.
Wow, really? Closer than the humans?
Sometimes, yeah. It suggests the LLM really grasped the core ideology, maybe even more consistently than individuals within the party.
Okay, that's pretty impressive for the data generation side. What about using it for pre-training? Did that help?
That was the second key finding, and yes, it definitely helped. Initializing the model with that synthetic data significantly cut down the errors in predicting user responses.
So better guesses about how people would answer unseen questions.
Exactly. And importantly, it also boosted the accuracy of candidate recommendations, especially for those crucial first few users interacting with the system.
So it directly tackles the cold start problem by giving a better experience right away.
Precisely. It shows LLMs have real potential here, particularly in domains like politics, where they have a lot of textual data to learn from.
You mentioned the statistical model earlier. Can you remind us what they used?
Sure. It was a combination approach. They used principal component analysis, PCA, first.
Right. For dimensionality reduction.
Yeah.
Making the data simpler.
Yep. Takes lots of questions and finds the main underlying dimensions. Then they use logistic regression, or LR, to predict the probability of a user agreeing with a specific question.
Okay, PCA, then LR. And how did it decide which question to ask next? That's the adaptive part.
They used a method called uncertainty sampling, specifically maximizing Giannini impurity.
Giannini impurity. Sounds complex.
It basically means the model picks the question where it's most uncertain about how the user will respond. It tries to ask the most informative question at each step.
Got it. Learn the most by asking about what you know least.
That's the idea. And the model wasn't static, right? It learned as more users interacted.
Yes, in their simulation, they had virtual users answer some questions. These users were based on real SmartVote voter data.
Okay.
After every group of 5 simulated users, they updated the model using the new answers collected, so it's learning on the fly.
Correct. And they also looked at how the initial synthetic data gets phased out. You don't want to rely on the fake data forever. They had a parameter, gamma, controlling the replacement rate.
Makes sense. You want the real data to take over eventually.
Of course, that's the goal.
And how did they measure success? What metrics?
2 main ones. For predicting how users would answer questions they didn't see, that's called missing value imputation, they used root mean squared error, RMSE. Lower RMSE is better.
Lower error, better predictions.
Okay. And for the main goal, recommending candidates, they used candidate recommendation accuracy, or CRA.
CRA. How does that work?
They used k-nearest neighbors. Basically, find real users who answered similarly to the simulated user, see which candidates those real users matched with best, and check if the system recommended those same candidates. Higher CRA means better recommendations.
Okay, RMSE for prediction error, CRA for recommendation quality. Got it. The paper laid out specific hypotheses too, right?
It did. Hypothesis 1 was about emulation. Could the LLM answer questions closer to the party line than the average real candidate?
And you said that was largely accepted.
Yes, the results supported that. GPT-4 was quite good at sticking to the party message, sometimes even more so than actual candidates.
What about the pre-training hypotheses?
Hypothesis 2A was straightforward. Pre-training with GPT-4 data leads to better prediction accuracy than starting cold. That was accepted too. Clear improvement.
Okay.
Hypothesis 2B suggested a break-even point exists, a point where the model learning purely from real data eventually catches up in accuracy to the pre-trained model.
That seems logical. Real data should win out eventually. Did they find that?
Yes, they did observe these break-even points. The initial advantage from pre-training phase as enough real data comes in.
Right. And the last one, 2C.
Hypothesis 2C was about the number of questions users answer. They thought maybe if users answer more questions before dropping off, that break-even point would happen sooner.
More data per user, faster learning.
That was the intuition. But the results were more complex. It wasn't a simple relationship. It seemed to depend on whether you were measuring overall prediction accuracy, RMSE, or the candidate recommendation accuracy, CRA.
Huh. So just getting more answers per person doesn't automatically mean the pre-training becomes irrelevant faster.
Not necessarily, or at least not in a simple, direct way. It highlights that the value of pre-training and how long it lasts depends on your specific objective.
Interesting nuance there.
Oh.
Okay, let's zoom out a bit. This idea of adaptive surveys isn't brand new. Where does it come from?
Oh, it goes way back, actually. Think early 20th century educational testing, item response theory, or IRT.
Intelligence tests and stuff.
Exactly. Psychometrics. The goal was always efficiency, accessibility, accurately, without asking tons of irrelevant questions, either too easy or too hard.
Tailoring the test to the test taker.
Precisely. That core idea then got adapted into political science for measuring ideology, what they call ideal point estimation.
Finding someone's spot on the political map.
Right. Early on, it was often just a single left-right dimension, simpler models. But as computers got more powerful, they moved to multidimensional models, capturing views across different policy areas, like economy, social issues.
Which is much closer to how voting advice apps work today,
Right.
trying to place you in that multidimensional space.
Exactly. VAAs and these spatial models are direct descendants.
And this cold start problem, it's not unique to surveys, is it?
Not at all. It's a classic problem in recommender systems.
Yeah.
Think Netflix or Amazon needing to recommend stuff to a new user.
Right. What do they recommend when they know nothing about you?
Common solutions there are things like suggesting popular items or maybe some simple heuristics, or even explicitly asking for preferences that's active learning.
So using LLMs to generate data is a new approach to this old problem.
It is, and what's particularly novel about this paper's approach is how they're using the LLM.
How so?
They're using it to generate training data for the existing statistical model, the PCA and logistic regression one. They aren't having the LLM be the recommendation engine itself.
Ah, so it's not replacing the model, just feeding it.
Exactly. This maintains more observability and explainability. You can still inspect the PCALR model, understand its parameters. That's really important, especially in politics, where you need transparency about why recommendations are made.
Instead of just having a giant LLM black box making decisions.
Precisely. There's other work using LLMs for synthetic data, showing they can mimic response distributions well, even in politics. Some discussion around potential biases, or maybe reducing human diversity if you rely only on AI surrogates. But here, the key is, it's for pre-training. The synthetic data gets replaced by real human data over time. It's a kickstart, not a permanent replacement.
Okay, that's a crucial distinction. Let's try and boil this down. What are the absolute key takeaways for someone listening?
Okay, first, GPT-4 can actually generate pretty realistic political survey answers, lining up well with party stances, sometimes even better than real people. Second, using this fake but realistic data to pre-train adaptive survey models gives them a significant performance boost right out of the gate. It really helps tackle that cold start problem.
Got it. What else?
Third, this pre-training advantage isn't permanent. As real user data flows in, the model learns, and eventually, a model trained only on real data will catch up. There's break-even point.
Okay, pre-training helps early, but real data matters long-term.
Exactly. And how quickly you reach that break-even point isn't just about how many questions people answer. It's more nuanced and depends on what you're trying to achieve, general accuracy or specific recommendations.
And there's this trade-off, managing how quickly you replace the synthetic data with real data.
Right. You need a strategy like gradually phasing out the synthetic stuff to balance the initial boost with long-term adaptation to real users. And of course, we have to remember potential LLM biases, and that performance depends on the LLM's knowledge of the specific domain.
So thinking practically, what are the real-world implications here? Where could this actually be used?
Well, the big one is deploying adaptive surveys in new contexts. Imagine launching a VAA for an election where you have zero historical data. This approach could make it viable, make it work reasonably well from day one.
So potentially improving voter engagement in places without established tools.
Could be. Or for wiki surveys where you want public input on policy priorities, but people drop off if it takes too long. An adaptive survey, pre-trained like this, could get you useful insights much faster.
Faster insights. That sounds useful for polling too, right? Especially on new, emerging issues.
Definitely. Understanding public opinion quickly on something that just popped up. LLM-boosted adaptive surveys could be more targeted and quicker than traditional methods.
Are there ethical things to consider? Using synthetic data in politics.
Absolutely. Transparency is key. Users should probably know how the system was initialized. And ongoing monitoring is crucial to ensure the model doesn't inherit or amplify biases from the LLM as real data comes in and potentially corrects things.
All right, got to keep an eye on it. Okay, let's shift gears to our novel notions segment. Based on this paper, what wild ideas or future research directions does it spark?
Okay, one idea builds on that synthetic data generation. What if you used generative adversarial networks, JNs, to refine the data after the LLM generates it?
JANs, like the things that generate deepfake images.
Yeah, sort of, yeah. You'd have the LLM, say GPT-4, act as the initial generator. Then you train a discriminator network on the real SmartVote candidate data.
So the discriminator learns to spot fake versus real answers.
Exactly. And the generator, the LLM output essentially, would have to learn to produce even more realistic, nuanced answers to fool the discriminator. The paper mentioned the GPT-4 data sometimes lacked a bit of variance compared to real data.
So the JAN could push it to be more varied, more human-like.
Potentially, yeah. It could maybe address that limited variance issue and lead to even better pre-training data, maybe getting the model accurate even faster. It's like an AI arms race to make better fake data.
Okay, that's a cool concept. Using AI to police AI for better results.
What else? Another thought is about how the synthetic data is used in pre-training. Instead of just replacing it all uniformly as real data arrives. What about dynamic question-specific weighting?
Meaning?
Well, maybe you could analyze how confident or consistent the LLM was when generating the synthetic answer for each specific question.
How would you measure that?
Maybe by trying slightly different prompts for the same question and seeing how much the LLM's answer varies. Or maybe looking at internal LLM confidence scores, if available.
Okay, so you get a sense of which answers the LLM is sure about.
Right. And for questions where the LLM seems highly confident and consistent, maybe you trust that synthetic data point more. You could weight it more heavily in the initial training or keep it around longer.
And for questions where the LLM seemed uncertain or waffled a bit.
You'd phase out that synthetic data faster as soon as real answers come in for that specific question. It makes the learning process more adaptive itself, focusing the pre-training benefit where the LLM's knowledge is strongest.
So a more selective use of the synthetic knowledge. That's clever.
It's an idea, anyway. Could make the transition from synthetic to real data even smoother and more efficient.
These are really neat extensions. It just shows how LLMs aren't just about understanding language, but generating useful information artifacts.
Absolutely. And it's worth stressing, these are just speculative notions, right? Food for thought.
Of course, just exploring possibilities. So wrapping things up, the main takeaway is pretty clear. LLMs look like a really promising tool for cracking that cold start problem in adaptive political surveys.
Yeah, by generating useful pre-training data, they offer a way to make these powerful survey tools more effective right from the beginning, especially when you don't have existing data. It's a shortcut to getting them working well.
Definitely an efficiency gain for anyone developing these systems. And for our listeners, if you want the nitty-gritty details, do check out the link to the paper in the description.
It's worth a read, and maybe leaves us with a final thought to ponder. As these LLMs get even more powerful, what other corners of social science research might be transformed by using synthetically generated data?
And what safeguards or new methods will we need alongside that?
Good questions. Lots to think about there.
Indeed.
Yeah.
Thanks for joining us on this deep dive. We'll catch you on the next one.